In today's session, we will start with a new chapter, that is elasticity. In this chapter, we will learn about what is meant by elasticity, what are elastic materials, then what is plasticity, what are plastic materials, some examples regarding both elastic and plastic materials, and why elastic materials knowledge is important in the field of engineering. Then we will learn about what is stress, what is strain, different types of stress, different types of strain, and different types of models of elasticity, that is the ratio of stress by strain. Now, we will start with what is meant by elasticity. Now, if you consider any solid material, when you apply an external force, if that solid material's dimension changes, and then if you remove the applied force or if you remove the applied deforming force, then if the solid material's dimension regains its original shape, size, length, volume, then such kind of property we call it as elasticity, or such kind of material we call it as elastic material. Now, if it is an elastic material, what happens is that whenever you apply an external deforming force, the whole solid materials or whole solid object deforms. Whenever you remove the applied deforming force, what happens is that all those particles which has displaced from its original position because of the deforming forces, all those particles they regain its original position, and because of which there will be regain of its original length, original volume, and original shape or size. So, this kind of materials we call it as elastic materials. It is a property by virtue of which material bodies regain their original shape and size after the removal of external deforming force. So, when an external force is applied, there is change in length, volume, and shape. When the applied force is removed, the body regains its original length, volume, and shape. Such materials are called elastic materials. Steel, glass, rubber, gold, So, we can define plasticity as it is a property by virtue of which material bodies attain permanent deformation when an external deforming force is applied. So, in the case of plastic materials, whenever an external deforming force is applied, the material bodies regain, they attain permanent deformation. So, such kind of property we call it as plasticity, and the materials which does not regain its original size and shape even after removal of applied deforming forces are called plastic materials. So, in the case of plastic materials, even after the removal of applied deforming forces, the body or the material does not regain its original shape and size, and such kind of materials we call it as plastic materials. Some examples of the plastic materials are you can write examples is wood, PVC, etc. So, these are some of the examples of the plastic materials. We will discuss two topics. One is called as stress and second one is called as strain. Now, what is mean by stress and what is mean by strain? Now, let us start with stress. Now, whenever you apply the external deforming forces in the body, the particles of the body tends to displace from its original position. Now, because of the applied force. So, because of the displacement of the particles from its original position, there is deformation. Now, whenever you remove that applied external force, what happens is that all those particles they tend to regain its original dimension. Now, whenever the body tries to regain its original shape and size, what happens is that a restoring force is set up in the body. The restoring force is trying to bring back the object to its original dimension. Whatever the restoring force which is set up in the body, that restoring force is trying to bring back the object's dimension to its original position. So, that restoring force applied per unit area of a body is called as stress. So, we can define stress as the restoring force per unit surface area is called as stress. As I said, whenever you apply an external force, the body displaces, the particle in the body displaces or the body deforms, and if the body is elastic, then a restoring force is set up in that elastic body, which leads to the regain of all the dimension of the body. For example, the body regains original shape, original length and original volume. So, such a restoring force which is set up in the body per unit surface area is called as stress. So, we can write stress as restoring force per unit surface area, or stress as restoring force per unit. Force is Newton and this is meter square. So, unit of the SI unit of stress is Newton per meter square. So, this is what is mean by stress. Now, similarly, we have another parameter or another physical parameter called as strain. Now, whenever you apply an external force or external deforming force, and if that body is elastic or even if it is plastic, what happens is that there is some strain developed in the body because of the change in length, shape and volume, or in terms of physical parameters because of change in length, breadth and height. Now, because of this change in length, height and breadth, what happens is that there is change in the volume of the object, there is change in the shape of the object and size of the object. And if that is elastic, the change is not permanent up to the elastic limit, and if that material is plastic, the change will be permanent. And this change in length and the original length ratio, we call it as strain. So, strain can be defined as the ratio of change in dimension to its original dimension. Now, the dimension can be change in length, the dimension can be change in volume, the dimension can be change in the cross sectional area. Strain as change in dimension to its original dimension. Since we are considering the same parameters in the numerator as well as denominator, strain is a physical quantity which has no units. So, this is regarding what is stress and what is strain. Now, depending on the direction of the applied force onto the object, there are different types of stress and there are different types of strain which has been classified based on the application of the force on the body and based on the dimension changes which takes place by the body. Now, as I said, depending upon the force applied or depending upon the direction of the force applied onto the body, that stress can be classified into three types. We will start with the first one. Longitudinal, it is also called as normal stress. Now, what is this longitudinal tensile or normal stress? Now, let us consider an elastic object which is suspended to the horizontal wall. Let us consider a string of elastic object, and one end of the elastic object is fitted to the wall and other end is left free, and to the free end of the elastic object will apply a force by loading a mass of gram mkg. Now, as soon as we load the mass, what happens is that the elastic object expands and there is increase in the length of the object. Let L be the length of the object. Now, because of the mass applied, a force is being acting in the downward direction. The force is a product of mass times acceleration due to gravity, and because of the force which is acting in the downward direction, the elastic string expands by a length x. There is change in length is taking place because of the force applied in the perpendicular direction to the object. Now, this is the object and the force is being applied in the perpendicular direction to this object or normal direction to this object. So, such a kind of stress which is developed in the object because perpendicular force is being applied or a normal force is being applied which leads the change in length of the object. We call such kind of stress as longitudinal tensile or normal stress. So, we can define the longitudinal tensile or normal stress as the restoring force acting in the normal or perpendicular direction per unit surface area of an elastic material. So, this kind of stress we call it as the longitudinal tensile or the normal stress, where the restoring force is acting or the force is acting in the perpendicular direction or normal or perpendicular direction per unit surface area of a elastic material. Now, second one, is volume or compression stress. Now, let us consider an object or let us consider a cube. Let the elastic material or let the elastic object we are going to consider is a cube, a three-dimensional cube. Now, in the case of the cube, what we will do is we will start applying the force in the normal direction to all the surfaces of the cube. Apply force in the normal direction to all the 6 surfaces of the cube. Now, whenever you apply the force in normal direction to all the 6 surfaces of the cube if it is the elastic material, what happens is that the cube goes on getting compressed. Why it is being compressed? Because we are applying all the forces uniformly. It may be uniform forces, it may be ununiform forces, but the forces are being applied in normal direction to all the surfaces of all the 6 surfaces of the cube, and since the compression is taking place, there is change in the volume of the cube. So this kind of stress, or this kind of stress wherein we are applying the force in the normal direction to all the surfaces, to the surface area of that object, is called as the volume stress or compression stress. The force applied normally the surface of the object per unit surface area of the object is called volume stress. So here the force is being applied normally to the surface area of the object per unit surface area, that we call it as the volume stress. So now the third type of stress is called as shearing or tangential stress. In the case of shear or tangential stress, the force is being applied in the tangential direction or the parallel direction to the surface of the object. Then because of which there is change in the cross sectional area of the object. So such kind of stress we call it as shear or tangential stress. Unit area, the force applied in tangential direction per unit area of the elastic material, we call it as shear or is called shear or tangential stress. So these are the 3 different types of stress which is based on the direction of the applied force. Now in the case of longitudinal stress or tensile stress, the force is being applied in the perpendicular direction to the object, because of which there is change in length. In the case of volume or compression stress, in the case the force is being applied in the normal direction to the surface of the object, because of which there is change in volume. Now here in the case of shear or tangential stress, the force is being applied in the tangential direction to the surface of the elastic material. So because of it there is change in the cross sectional area. So these are the 3 different types of stress. Now based on the direction of the force applied, there is change in the shape of the object also, or there is change in the dimension of the object also. Based on the change in the dimension of the object, there is again 3 different types of strain, and apart from which there is an additional strain which we call it as the lateral strain. First one is called as longitudinal or tensile strain. We can define the longitudinal strain as the ratio of change in length to its original length because in the case of the longitudinal strain or in the longitudinal stress, basically there is change in length taking place. So, if we take the ratio of the change in length to its original length, then we call it as the longitudinal strain or the tensile strain. Longitudinal strain is equal to the ratio of change in length, I will call it as delta x, and original length I will call it as x. So, the ratio of change in length is delta x and original length is x. An additional strain, which call it as lateral strain. So, how does this lateral strain develop, or what is this lateral strain? Now, whenever you apply a force in the perpendicular direction to the any surface of the cube, apart from changes in length, there is also decrease in the diameter or decrease in thickness of the material. Is the ratio of change in diameter to the original diameter of elastic material, or else lateral strain is equal to change in diameter divided by original diameter. So, we can write the change in small change in diameter as delta small d and original diameter as d. We define the volume strain or bulk strain as, or compression strain as, the ratio of change in volume to its original volume. Now, whenever we apply the force in the normal direction to the surfaces of an object, what happens is that there is change in volume takes place. Now, the ratio of change in volume to the original volume, that gives us the volume strain, or we call it as a bulk strain as well as compression strain also. So, we can write as the ratio of change in volume to its original volume. So, volume strain is equal to change in volume divided by original volume. So, we can give the mathematical representation as change in volume and call it as delta small v and original volume as the last type of strain is called as the shearing strain. Now, the shearing strain is developed whenever you apply the force in the tangential direction to the surface of the cube. There will be change in the cross sectional area because there will be changes in the layers on the surface of the given elastic material in the perpendicular direction. Lateral displacement between the two layers to the perpendicular distance between the two layers. So, if this is a face of a cube and we are applying the force in the tangential direction to the upper layer of the cube, the lower layer of the cube is fixed, then there will be deformation. In the more the deformation will be in the upper layers of the cube, and there will be less deformation in the lower layers of the cube. That's why this is L, and I'll call this as delta L, and this is theta. So we can write shearing strain is equal to delta L by L, that is equal to theta. So these are the four different types of strain which are developed because of the different types of force applied on the object.